This equation is so cursed. If you know anything about logarithms, the fact that this equation is actually true, it's really mind-boggling. And if you know anything about me, you should know that I really want to find more cursed equations just like that one. So I put myself to work and I have found not just one more example, but infinitely many examples like this one, except that all the other ones involve fractions, and that's the only one with integer coefficients. Let me show how I found this one and infinitely many others like that one. If you want to find positive numbers x and y that satisfy the equation in logarithms, because a sum of logarithms is the logarithm of the product, this happens if and only if 1 plus x plus y is equal to the product of 1x and y, so just xy. And 1 plus x plus y equals xy is the equation of a hyperbola. This hyperbola goes through 2, 3, and 3, 2. Those points correspond to that solution. And it also goes through -1, 0, and 0, -1, but those solutions would correspond to values of x or y that are negative, and I couldn't take logarithms, so those do not work. What I'm looking for are more points on this part of the hyperbola. Now, there are ways to parameterize all the points on a hyperbola using what we call stereographic projection. You take a known point, a line through that point of a slope t, and then find the second point of intersection. That point of intersection will be given by this intersection of two curves, and these are the possible coordinates. One is that x is -1 and y is 0, the known point, and the other one gives me the other point, which parameterizes every other point on the hyperbola. So these are all the points, and what that tells me is that the solution is that the logarithm of 1 plus t plus 1 divided by t plus 2t plus 1 is the sum of the three logarithms. And for example, when t is 1, I get the equation that we started from. When t is 2, I get a new triple of numbers that gives me a new example of a triple sum of logarithms. Well, what about something more general? The logarithm of the sum of three numbers is equal to the sum of their logarithms. That will be true if and only if this is true. And if I solve for z, as long as the denominator is not 0, then z has to have this value. And if it has this value, it works. So I get an equation of this type for any values of x and y. So for example, when x is 2 and y is 4, the z value is 6/7, and I get this cursed equality.